And we're back. Welcome to part two of topic 25, systems of inequalities, the word problem section. So this is problem 2, the bottom problem on your foldable, where Nathan makes $10 an hour delivering pizzas and $5 an hour babysitting his sister. Now, honestly, just looking at these wages right here, this is absolutely ridiculous. Ridiculous. Because we all know that the minimum wage in Massachusetts is $12 an hour. So Nathan is not really making that bread here. So he's got to fix that. But he wants to make at least $40. But his mom said he has to work for less than 6 hours a week. So Nathan has to listen to mom here. So we're going to start off with cubes. Circle our numbers. We got $10, $5, $40, and 6 hours. Notice how I circled the units here. That's really important that we pay attention to. It's going to help us with writing our inequalities. And let's go into boxing some important words since we don't have a question that's explicit right here. So we're dealing with delivering pizzas, and we're also dealing with babysitting. So those are probably our two variables. Now he wants to make at least $40, and his mom says he has to work for less than 6 hours a week. Oh, also note how we have an and here. That's going to be a plus. So that's going to be helpful when writing our inequality that we know to use addition. So if Nathan wants to work at least $40, wants to make at least $40, can he make $40? Yes. Can he make $30? He could. Wouldn't really be happy with it. Can he make $45? $50? Do I hear $60? Absolutely. So he can make $40 or more. $40 here is the minimum that he wants to make. Ideally, he would like to make more, but we'll see. Now, his mom says he has to work for 6 hours. I don't know, maybe he has some homework to do. So if he needs to work 6 hours, less than 6 hours, can he work 6 hours? No, his mom's going to be pretty picky on that. Can he work 5 hours, 4 hours? Yes. So he can work strictly less than 6 hours. So going into identifying our variables, here we know that Nathan is delivering pizzas as well as babysitting, but we don't know for specifically how long each week. So our x variable is going to be our number of hours delivering pizza and our y is our number of hours babysitting. So now it's time to identify what our inequalities will be. Our first inequality, again, if we want to make our units consistent, Nathan makes $10 an hour delivering pizza, which is denoted by our x variable, and $5 an hour babysitting, and he wants to make at least $40. So since we know it's at least $40, it could be $40, but it could also be more than. So that's our first inequality. Our second inequality is we know that Nathan is both delivering pizza and babysitting. We just don't know for how long. So we know it has to be less than 6 hours, that total. So there's our second inequality. Now, it's similar to the last word problem where we had our inequalities written in standard form. It's going to be easier since we are going to have to graph it to convert them to slope-intercept form. So I'm going to rewrite my first inequality up over here, and we can solve for slope-intercept form. So here we have 10x plus 5y is greater than or equal to 40. Now, in order to solve for our y variable, we need to move everything that is on that side that is not y away from it. In that case, we're talking about x. So we're going to subtract our 10x from both sides of our inequality. On the left side, it cancels, reduces to 0, and we're left with 5y greater than or equal to. Now our 40 and negative 10x, these are not like terms, so we cannot combine them. We can write it still as 40 minus 10x, but if we want to write it in slope-intercept form, we can identify that this is actually negative 10x plus 40, because this 40 here is positive. One more step to go. We know that 5y really means it's 5 times y. So in order to undo multiplication, we are going to divide. You get a 5, you get a 5, everybody gets 5. So y is greater than or equal to negative 10 divided by 5 gives us negative 2x, and 40 divided by 5 gets us positive 8. So our first inequality here is y is greater than or equal to negative 2x plus 8. Now our second inequality, thank goodness, it's a little bit shorter. So we just have x plus y is less than 6. In order to get our y alone, we're going to move our x, subtract x from both sides, and get y is less than negative x plus 6, because we know again that this is a positive 6. And here is our second inequality. Beautiful. So if we want to graph to actually figure out how many hours Nathan does work for each job, I know you're all dying to know, we're going to first label our axes. We know that x is going to be our number of hours delivering pizza. Dang, couldn't have chosen shorter jobs. Pizza. And our y is number of hours babysitting. Good. So I'm going to rewrite our inequalities just so we have them for reference. We're dealing with y is greater than or equal to negative 2x plus 8. And we also have y is less than negative x plus 6. So looking at our first inequality, we know that since y is greater than or equal to, this is going to be a solid line. And our y-intercept is 8. So we're going to count on the y-axis up 8. 1, 2, 3, 4, 5, 6, 8. And our slope is negative 2 over 1. So we're going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And make this with a solid line. Whoa, that is not straight. Goodness, I need a ruler. Okay, when dealing with shading, since its y is greater than or equal to, we're going to shade this entire big section here. Okay. And for our other inequality, y is less than negative x plus 6. This is really a negative 1 over 1. So we're going to start at our y-intercept of positive 6. 1, 2, 3, 4, 5, 6. And our slope is negative 1 over 1. So we're going to go down 1 to the right 1, down 1 to the right, 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 down 1 to the right. And because we have just less than, this is going to be a dashed line. So we're going to connect this with a dashed line. And again, since y is less than, when shading, we're going to shade below. So if you notice here, we just have this tiny little section that could be possible answers. Now, students in past have asked me, Miss Reed, can we choose a point that's on the line? So here's where I say, be careful. Because we know that solid lines include solutions, but dashed lines exclude solutions. And we want a point that's going to satisfy both of these inequalities. So I like to choose a point that you can actually see within that section. Something that might be like 1, 2, 3, 4. 4, 1 would be a really good choice. And if we want to write our solution in the context of the problem, we can say Nathan delivers pizzas for 4 hours and babysits for 1 hour. And there you have it. And in order to double check that this actually works, we can plug it into our two inequalities and we are all set to go. So there you go. I know you guys were dying to know how long Nathan actually had to work each week for his 2 jobs. And now your hearts can be finally content.